All right, grade 12s, this is just a little bit more geometry for those who are wanting to start on it. We left off with theorem 1, which was that if a line is drawn parallel to one side of a triangle, that the other two sides will be cut in the same proportion. So this one is called the converse. When it says not for exam purposes here, it's talking about the proof. You do need to know this for exams, but you don't need to know where it came from. You just need to know the rule. Right, so it says here, if a line cuts two sides of a triangle proportionally, then that line is parallel to the third side. And whenever you use this theorem, you're going to use this reason here is a nicer one to work with. Okay, so line divides two sides of triangle in proportion. So here they're telling you it's in proportion, so then we can conclude that the lines are parallel. Before you were told the lines were parallel, and so you could conclude the proportion. So it's the opposite now. So they have told us that we have two sides with equal ratios, and so we can conclude then that we have parallel lines. So that DE is parallel. So you don't need to know where they got this from. All you need to know is that if you want to use it, if you need a parallel line for something, you need maybe a parallel line for angles, for fun, for corresponding co-interior, or alternate, then you can find sides in proportion and then conclude parallel lines. All right, so looking at this example, this is a numerical example. It says in triangle ABC, we have 10 centimeters for AD, 3 for DB, AE is 15, and EC is 4.5, as you can see. And then we need to prove that the lines are parallel. So in order to do that, we need to prove proportion. Okay, so we're going to start with AD over its side DB. You can use any combination. You could use the whole side if you want. This is using top to bottom, as long as the sides are matching on the other side. So that's going to be 10 over 3. All right, and then when we're working with the other side, we're going to use AE to EC. So we use big to big, small to small. And if you simplify this 15 to 4.5, it's the same as saying 15 divided by 9 over 2, which is the same as 15 times 2 over 9. And in this case, we can simplify, and it does end up getting you, well, get you 30 over 9, which dividing by 3 is 10 in 3. Right, so you don't have to show us so much, but the idea is that we are trying to get equal ratios. So we need to conclude now. So we'll say, therefore, the ratio of AD to DB is going to be equal to AE to EC. And so therefore, DE, the line, is parallel to BC. And the reason you're going to use is this one here in the blue, line divides the sides of a triangle in proportion. Right, so it's that simple. We are working with numbers there. Let's look at one with just working with variables. Okay, so example 6. You don't have these examples, by the way, in your textbook. This is from another textbook, so you have to work with these ones and the PDFs that are on the Google Classroom. These would be given to you normally in class, so when we get back, we will give you the printed notes of it. All right, in this one, in example 6, triangle ABC and ACD are given, and you have XY parallel to BC and YZ parallel to CD. So let's do this using colors. Colors are very, very useful. So I'm going to do this one in green. That is the one triangle with its set of parallel lines. And then I'm going to use different color for the other triangle that they mentioned with parallel lines. Okay, and then the aim is to prove that XZ is parallel to BD. So that's what we're trying to get to. So the green and the red is what we know. So I'm going to go with looking at the green. It's sometimes a good idea just to draw the triangles out. So it's got A, XY is the parallel line, BC is the other parallel line. So we know from Theorem 1, there we go, that AX, not XY, AX to XB will be equal to AY over YC. And the reason for that is line parallel one side of triangle. That was given. Okay, they told us that XY is parallel to BC. Then in our red triangle, okay, we have A, YZ, CD, and they told us those are parallel to each other. So we know that AY over YC is equal to AZ over ZD. Reason again, line parallel one side of triangle, and that's because YZ was parallel to CD. Please write your reasons next to there. All right, so now what we've got to notice is that we have something in common here, the AY and the YC, and the reason for that is because it was the overlapping side. So because it's the overlapping side, we call it the linking side. It means that we can link AX equal to AZ. All right, so let's write this all out neatly now. So you would write this as your following reason. So you would say AX over XB is equal to AY over YC. Line parallel one side of triangle. You can put the parallel lines there if you want. And then, but AZ is parallel to is equal to AY over YC because we have a line parallel one side of the triangle that they gave you, YZ parallel to CD. Okay, so then you'd say, therefore, AX over XB is equal to AZ over ZD. You don't have to give any other reason. It's just a logical flow from there. And so now going back to our picture, we can see that. So I'm just going to now highlight or look at these sides. So AX to XB, AZ to ZD. And if we highlight this where they're working, it's in a triangle that is A, B, D, and then X and Z. Now we know that side is in the same proportion to the other side, which means that these two must be parallel using this converse. So we'd say from this point, therefore, XZ is parallel to BD because there is a line, or they are lines that divide the sides of this triangle in proportion. Okay, and the proportion is that the AX to XB, AZ to ZD. All right, so it's quite a simple concept. It's nothing extra really from that. And then just a quick recap, this also links to this theorem. Theorem 2 and Theorem 2 converse are linked to Theorem 1, the proportionality. It's just a specific case. So there is, in a midpoint theorem situation that you learned about in grade 10, you know that if we have AD the same length as DB and AE the same length as EC, then the line that is breaking it in half must be parallel. All right. As well as that, so because of the midpoint relationship on each side, right, it means that the line is parallel. So because there is a line that divides the sides of the triangle in proportion, the proportion just happens to be 1 to 1. They equal. Then it's a special case of theorem 1, so then we know that the line is parallel. In this case, it's part of like the converse. So we know the sides are in proportion, so we then can conclude parallel. But instead of working with the theorem 1 and theorem 1 converse reasons, remember you're allowed to just say midpoint theorem. All right. Then for theorem 2 converse, the midpoint converse, it's just saying if you know you've got parallel lines and you've got one side is divided in half, we know that the other side is also going to be divided in half. All right. And for that, you could just say converse midpoint theorem. Then when you're working also with midpoint theorem, you know that the line in the middle of the triangle is going to be half the size of the line that it is parallel to. All right, and that's the same for the converse. So there's nothing different with midpoint theorem. It's completely the same as from grade 10. It's just a special case of it. So when you're working with proportion that's equal proportion, 1 to 1, then instead of using the theorem 1 reasons, you use midpoint theorem. And that's it. In the next video, I'm going to be showing you the next big theorem, the one called theorem 3, the similarity theorem, and then that will have some exercises attached to it.